Chapter 4.8 is the last section of Chapter 4, and here we will study applications and models of trigonometry. Basically, we are going to take everything that we have learned throughout the chapter and apply it to different word problems. All right, so a lot of this is going to involve inverse trig, a lot of it's going to involve right triangle trigonometry, and we'll also talk a little bit about navigation in this section as well. All right. We'll get there. I know it's exciting. Let's start off with a simple word problem. The sun is 20 degrees above the horizon. As it sets over a 600-foot tall building, determine the length of the shadow that is cast by the building. Round your final answer to one decimal place. So you'll notice also with these word problems, we're going to be using a lot of calculators. Okay, make sure you have a calculator handy. So when in doubt, draw it out. Always a good idea to start with a picture. Here we have our sun. It's 20 degrees above the horizon. And here we have our building. We know that the building is 600 feet tall, and the shadow that it casts will be here on the ground, right? That is the distance that we are trying to determine. Let's give it a variable name x. So we are trying to find x here. Notice that in drawing this picture, we have generated a right triangle. And with respect to our 20-degree angle, we are working with the sides that are opposite and adjacent to our angle 20 degrees. Well, is there a trig function that relates opposite and adjacent sides of a right triangle? Yes, that is tangent. Remember, don't forget about your right triangle trig. You'll have to recall the acronym SOHCAHTOA. What does this mean? Well, sine of theta is equal to the ratio of our opposite side divided by our hypotenuse. The cosine of an angle theta is equal to the ratio of our adjacent side divided by our hypotenuse. And tangent of theta is equal to the ratio of the opposite side divided by the adjacent. SOHCAHTOA. So in this case, we're working with opposite and adjacent sides. Therefore, we want to set up an equation using our tangent trig function. In this case, the tangent of 20 degrees is equal to 600 divided by x. Tangent of theta is equal to the opposite over the adjacent side. Well, to solve for x, we're going to multiply both sides by x and divide by tangent of 20 degrees, giving us x is equal to 600 divided by the tangent of 20. We then plug this into our calculator to get our final answer. X is approximately 1,648.5 feet. Notice that when you plug this into your calculator, make sure your calculator is in the proper mode. Because our angle measures are measured in degrees here, you will want your calculator to be in degree mode. Otherwise, you will get the incorrect answer. All right, if you're working with angles in degrees, make sure your calculator is in degree mode. If you're working with angles in radians, put your calculator in radian mode. Generally, if we're dealing with triangles, right triangles, calculator should be in degree mode. Let's look at another one. An engineer is designing a 75-foot cell phone tower shaped as an isosceles triangle. The base of the tower is 30 feet wide. Determine the angle of elevation of the outside support beam to the top of the tower. So here we have our cell phone tower. We know that it's 75 feet tall. The base is 30 feet wide. And we want to find an angle of elevation. All right, so that's from the ground up of this outside support beam. All right, let's call that angle theta. We are trying to find this angle theta. Well, how are we going to do this? We don't have a right triangle here, but what we can do is we can drop a vertical line from the top of our cell phone tower down to the base and generate two right triangles, allowing us to work with our right triangle trigonometry. Okay, and this is an isosceles, right? An isosceles triangle, meaning that these two sides here and here are going to be the same length. And because of that, we are actually going to bisect the base of our cell phone tower, meaning that the distance here is going to be 15 feet. Okay, we've got a right triangle to work with now. Let's think about what we're trying to find or what we're trying to deal with here. We're trying to find this angle theta. We know, with respect to our angle theta, this opposite side, and we know the adjacent side. Is there a trig function that relates opposite and adjacent sides? Yes. The tangent of theta is equal to 75 divided by 15. And 75 divided by 15, that reduces into 5. So the tangent of theta is equal to 5. Well, our goal here is to find the angle, right? Determine the angle. That means we need to solve for theta. Algebraically speaking, to isolate theta, that means we need to undo taking the tangent of theta. And what's the inverse operation of taking tangent theta? Taking the inverse tangent. So we take the inverse tangent of both sides of our equation. The inverse tangent of the tangent of theta is equal to the inverse tangent of 5. And notice here on the left-hand side of our equation, these inverse operations, they cancel out, leaving us just with theta is equal to the inverse tangent of 5. And from here, we can plug this directly into our calculator. Okay? So, to type in inverse tangent into your calculator, you are going to select second and then hit tangent. All right, second and then tangent. Second tangent 5 and hit enter. If your calculator is in radian mode, you will get theta is approximately 1.37 radians. If your calculator is in degree mode, which most likely it is from the last problem, you should get theta is equal to 78.69 degrees. Now, both of these are acceptable answers, all right? Just make sure you know whether or not your answer is in radians or degrees, and you can tell by the mode that your calculator is in. Again, most commonly, if we're working with triangles, your answers are going to be in degrees. Make sure that you are being very specific, though, and you have the correct measure. If you told me 1.37 degrees was your answer, you would be wrong. If you told me 78.69 is your answer, you would also be wrong. It's only degrees if it includes a degree symbol. No degree symbol implies that we're talking about radians. So make sure that you are very specific with your answer. Okay, so there we have it, our angle theta. And again, if you're looking for an angle, you're going to have to use inverse trig. Inverse trig functions give us out angles.